Okay, so today is Monday, Halloween, and what we're going to do is finish the last section of chapter 4 and then do some review. So I want to do that first, and then we'll go after questions where people have had trouble. So this is section 4.6, and it's about square roots, and then it goes to the Pythagorean theorem. So here's the deal. Everything in mathematics that you can do, there has to be a mathematical way to undo it. So when you add, you can subtract. And when you multiply, you can divide, and back and forth. So one thing we've done already is do powers, like 5 squared, 5 to the second power, which means 5 times 5, which is 25 in the end. So if there's a way to do a power like square, there's got to be a way to undo it. And so this is what it looks like. It's this symbol here. It almost looks like division, but it has this little V thing. This is square root of 25. Ask the following question. Well, the answer's right here. What number multiplied by itself gives you 25? And so this is what helps you figure it out. But the answer is just plain ordinary 5. So it's the number, it's the root that produced 25. So there are a lot of perfect squares, and this is what I would call a perfect square, because when you do the square root, you get a nice, sweet whole number. So square root of 49 is 7. Square root of 1, don't be confused about that one. It is 1. 1 times 1 results in 1. Square root of 9. You see how this is working? So these are all perfect squares, numbers that were made by multiplying 2 numbers identical, like right up here. So square root of 9 is 3. So these square root numbers are useful, but you know what? Not every single number comes out really nice like these. So for instance, if you had the square root of 4, it's 2. But I want you to know, if for some reason you needed to do square root of 5, it's no longer good. It's no longer, I mean, there's an answer to it, but it's not something you can come up with. So this is why we have calculators, and one of the reasons. And so I'm going to go do square root 5, and hopefully we can see it. This number 2.236, whatever, that number, although it goes out about 8 or 10 places, is not the whole answer. It goes out to infinity. These numbers that keep going and going without repeating, no pattern at all, are called irrational. I don't know where they got that word, but it makes sense. They just have no pattern. They have no plan. They just keep going. Kind of like the number pi, 3.14159, and it goes out to infinity. And so what do you do with numbers like this? Well, you can't take that much. I mean, you can't ever write the whole number. It's impossible. So if, for practical purposes, write it, 2.2360679, and so on. If you needed it, there would be rounding instructions, because you can't write the whole thing. The exact answer would be square root of 5. That includes every last bit, as forever, how it keeps going. But for practical purposes, if somebody needed this and somebody said, okay, round it to the nearest hundredth, notice the TH, tenths, hundredths, right? You would go 2.2. What? 3 or 4?
4.
4 it is. Because the very next number is 5 or more, making this last number go up 1. Otherwise, it would have stayed 2.23. So this is what you do. This is the same is true with the number pi, which we haven't talked about, but most people have heard about it. Many times they'll round it to 2 decimal places. But that's not all of it. And so this is another example of a rational. So an irrational, let me spell it out for you, not rational. An irrational number, I think froze. So now, what are some of the kind of questions that come up with this? Well, let's see. Irrational, there's the word for numbers that go out forever without a pattern. And you can take them out to a million decimal places and still never see a pattern. And they basically know that there is no pattern. So some of the problems they might have, besides just plain square root of 25, which is just a simple answer, they might have problems like this. 4 times the square root of 16. Okay. Now, the 4 and the square root of 16 are right next to each other without a symbol in here. There's no plus sign, there's no minus sign, nothing. So what you have to assume when there's absolutely nothing is the assumption is it's multiply. So this becomes 4. The square root of 16 has a much better, simpler version of it. And so it's 4. And then you would multiply. 7 times the square root of, let's see, 64 plus 2 times the square root of 9. Okay, I just made that up. So square roots are in the same category as exponents. And so it would be a lot, it's done first before you ever consider the multiply. Remember the order of operation, parentheses first, exponent second. Square roots are in the category of exponents. And so square root of 64 is 8. This is 7 times 8. Plus square root of 9 is 3. At this point in time, the adding, of course, is last. You do the multiplying, 56. You do this multiplying, which is 6. And then you call it, in the end, 62. How's that? So that it's really not a big deal at all once you understand what a square root is. Now, if it's not a perfect square, then they're going to say in the instructions, would you kindly punch it up on a calculator? Well, I'm not going to test that, but there are a few questions in your homework asking you to use your calculator. Let's see. And so let's say we had the square root of 12. I would find it on my calculator. And I'm getting 3.46410. More, right? And so let's say they say round to the nearest 10th. The first place is the 10th place. So from this point on, none of these numbers will show up in the rounded answer. This number here will either stay 4 or go to 5. Which is it?
5.
That is correct. Okay, so that's a little bit of rounding. for practical purposes, if it's a perfect square, you can do it in your head. If it's not a perfect square, there is a way to do these out with a long, complicated division. There is a way to do them by hand. I've tried over decades to teach how to do it. And I could say, honestly, I'm not convinced I ever taught a single person how to do it. And it's not worth it, because here, the answer is just staring us right in the face, and we all have calculators. So I see no reason to do it by hand. Now, the other thing in this last section has to do with right triangles. And right triangles are ones that have out, usually they're marked like this. It's 90 degrees. So the two lines are perpendicular to each other. Now, somebody figured out, and I can almost guess how they did it, but somebody figured out that there's a relationship between the three sides when you have a right triangle, a triangle with a 90-degree angle. And so they typically use these three letters. The only one that needs to, you can place these letters in different places, but the only one to use our formula, the letter C for the longest side, is the one that's opposite the 90-degree angle, and it's clearly along a side. So the formula goes a squared plus b squared equals c squared. This is Pythagorean theorem. Why is it called that? Because the person, I think Greek, Pythagoras, figured it out. Probably others did as well, but Pythagoras gets the credit, and so we call it Pythagorean theorem. Now I'm going to do, here's my 90 degree. This is 3, this is 4, and this is missing. I'm going to do a nice one first. And so I'm going to call this A and this B. It really doesn't matter about if you call this A and this B, it doesn't matter. C matters because it's these two added together equal that larger side squared. So here I'm going to do it. A squared plus B squared equals C squared. We're trying to find the length of this. So I have 3 squared and 4 squared will equal C squared. So this little formula, okay, we know how to do this. 3 squared means 3 times 3, 9. 4 squared means 4 times 4, which is 16. And that together makes C squared. Now this, we're starting to use this little tiny equation, but we don't panic. 9 and 16 is 25. Now, does it look like this value here, this length of this is 25 units? That would be an awful lot, wouldn't it? See, this one's only 3, this one's only 4.
Yeah, that does seem like a lot.
It is too much. And now we look at the formula and we realize that's too much. It's C that's squared, that's 25. And what we really wanted was C, right? So remember what I said, if you can do something like squaring, you can undo it. And so literally what happens is you square root this to get C, and you square root this, and square root of 25 is 5. Doesn't that seem like a more reasonable answer?
Okay. Yeah.
So when you had C squared is 25, you didn't have what you wanted. You wanted plain ordinary C. And this is when we start to look at equations, that's our goal, to get it down to the letter and the answer. Okay? So this is kind of cool because there's lots of cases where you could measure two sides, but you're unable to measure the third side. I'm going to give you an example. So let's see. They use this in survey. I'm trying to think of a good one. Let me get the book out. We have two sides. Okay. Okay, this is the book. A ladder is leaning against the side of the building. And even though it's hard to look at, you can see there's a ladder there. If the bottom of the ladder is, what does it say, 8 feet from the building, and the height is 6. So I'm going to redraw it for you. The question is, how long does the ladder have to be? So let me get out of that. So here's the building. This measurement here is 8 feet. This is 6 feet. And this is where the ladder resides. So now you can see, so this clearly, this is the 90-degree angle. This is the longest side, which if we keep those 3 letters, it would be C. So A squared and B squared equals C squared. I have no idea how this is going to turn out, but let's find out. So I could call either one of these A and B, the 6 and the 8, but the C has to be singled out on a separate side, and that's what we're looking for. So 8 squared and 6 squared is C squared. Okay, so I put A in 8 for 8, B for 6. 6 times 6, 6 times 6 is 36, 8 times 8, 64. Now what? Can anybody tell me what would make a next step?
But the sum is 100, so then it would be the square root of 100,
Yes,
which would be 10.
exactly. So to get from C squared to C, we have to do square root. And so this is another good example where the numbers come out a perfect square. Square root of 100 is 10. And so that's your answer right there. So the ladder has to be 10 feet, or it's not going to fit. Okay. What do you think about that? Now, what would happen if it didn't come out? See if I can find one. Here's one. I suspect this is not going to come out. This one is 2. This one is 10. And how much is this? So I could call this A and this B. 2 squared plus 10 squared is C squared. Just keep simplifying until you get it down to a good number. This is 2 squared is 4. 10 squared is 100. And that's C squared. This is 104. And that is not a perfect square. And that's what I wanted to show you. So what do? To get C, which is what we really, really wanted, you take the square root of 104. Now, because it's not a perfect square, it depends on what they want. If they somehow say, okay, look it up on your calculator. And so you'd say, all right, I'll do it, doggone. So you would go square root 104. And then they would give you some sort of instructions about rounding. So let me write down exactly what I'm seeing here. 10.198039, okay? And the instructions on this particular problem was round to the hundredth. What is your answer?
10.20.
Yeah, I would actually, even though zero typically is dropped, because they asked for hundredth, I think I would give them give it like that. So the 19, because this was high, went up to the next number, which was 20. And so it's 10.20, correctly rounded. Okay. All right. So anyway, this is, see what you can do with this. There was one I didn't show you, and it goes like this. Let's see if you know this one. I made one a little bit higher. This is a fraction under the square root symbol. And so what you literally have to do is square root each one separately. Now, the square root of 81, I'm pretty sure you know. What is it?
9.
9. Now, this is another good one. Even though it's over 100. Does anybody know what it is? What times what is 144?
12.
It's not 10.
12.
I
because
think she said
square root of-
12.
Oh, did you say 12? I didn't hear it.
Yes.
12. It is 12. And so this is the thing. When you know that the square root of 100 is 10, the square root of 144 has to be higher. And so the question is, what number is higher? Well, 12, it has to be even, but it ends up being 12. So would you turn this answer 9 over 12? What do you think?
Did we reduce it?
Honestly, they love reducing. And so without looking directly at I made this problem up without looking directly. I just think.
So the
without
square
anybody
root,
forcing you, I think you need to reduce every time. They're not going to mark it wrong. And I think they might not accept that. Question?
so the square root of 81 over 144 is 3/4.
That's right.
Wow.
Okay. So we're learning some new things. That's all. Okay. So what I want to do, somebody had asked, I want to open this up to some review. Somebody had asked about decimals to fractions and fractions to decimals. And so the good part is if you have a decimal and you want to make it a fraction, if you can read it, you can do it. And so this is, remember, this is tenths, this is hundredths. So it's 7,500 over 100. Now, you know what you do with fractions, we just talked about it. If you have a fraction that needs to be reduced, let's do it. And so if you think of this as money, 75 cents out of $1 is what? Can you quickly reduce that?
3/4 of a dollar.
Yeah, 3/4. Or you could start dividing by 5 and take it. But I do think when you relate it to money, it's 3/4. You're actually dividing by 25. How many quarters in this? 3. How many quarters in this? 4. So we're relating it like that. And if you're used to money, everybody has a credit card, and so nobody uses money anymore. How's that? Yeah.
Can I give you one question to do for me
Yeah,
fraction.
let me finish this thing and I'll let you do the next one. So the next one has to do with, what if you have a fraction, any kind of fraction, and you want to make it a decimal? Again, if you can read it, you can do it. This is 5 fraction line divided by 8, which means when you write it out, the 8 is out here. And so don't get confused. But I think I've showed this before and I don't want you to forget it. You can take your fraction and the top number comes down. And then you kind of hide that. And the 8's on the outside and the 5's on the inside. And so one way or the other, you get these placed properly. This is a whole number, so this comes up. And so I'd say let's add a couple zeros. Maybe we need 3, I'm not sure. So 8 into 5 doesn't go, but it does go into 50. 8 times 6? 40. 8. Subtract 2. Bring down. 8 into 20 goes
2.
twice. 2 times 8? 16. 1 left over. Now, I kind of knew I needed to go one more place, because if I went one more place, here's a 0. 8 into 40 is 5. Why did I want to do that? Because now I have a remainder 0, which is ideal. If there's no rounding instructions, that's saying to me, just go a little bit further and you should have it. So 5/8 is actually 0.625. How's that? Okay. So somebody had a question. If anybody has anything, and then eventually I'll go to the review problems, but let's deal with these questions right now. What was the other question that somebody had?
Yeah, I have this question.
Okay, read it to me.
Change 0.0625 to fraction and then reduce to third.
So 0.625 is what I'm hearing, right?
0.0625.
Oh, there's another 0 here. Well, that's a real pain. And we want it into a fraction?
Yes.
I
And the
remember that problem.
Yeah, tenths, hundredths, thousands,
10,000.
thousands. So that's what we want to do first. 625 over 10,000. Okay.
Okay.
Now, I think dividing by 25, because this is like money again, would probably make this simpler. If I took 25 into 625, so I'm going to end up dividing both by 25 just because I can see it as money. Can you? And so 25 into this goes twice. This is 50. When you subtract, you get 12. You bring that down. 25 into 125 goes 5. So 625 divided by 25 is 25. This is cutting this down quite a bit. Now I'm going to take the same thing and divide by 25. 10,000. 1, 2, 3. So 25 into 100 goes 4. 4 times 25 is 100. And then it's going to be 25 into these 2 zeros are going to go 0. This is not done, but this is one heck of a lot better than the original. Now we have a fighting chance. 25 into 400. I think I'm going to divide by 25 again. Divide this by 25, because this is like money, and divide this by 25. 25 divided by 25 is 1. 400 divided by 25 is asking the question, how many quarters would you have if you had $4?
Yeah, it
Four,
would,
4, 4, 4. How many would there be?
5,
16.
16.
Yes.
Oh,
I could do that one by hand. I think seeing this as money would definitely do this for me. Because 625 and this is like $100 or something. Dividing by 25, cut this down to size. And then when I looked at the new problem, 25 over 400, I could again divide by 25. And 25 divided by 25 is 1. If you can't see this in money, then just divide it. 25 into 400. 25 into 40 goes once. 15 left over. 25 into 150 is actually 6. I keep thinking about money. Because $1.50 would have 6 quarters.
So when we change it to the fraction, we don't use any zero before the numbers.
No, because that is front zero, putting a 0 here makes no, you don't usually put.
Yeah,
a 0.
that's I
Yeah.
try many times, it's come out. That's,
Yeah. So it's tens, hundreds, thousands, 10,000s. That was the number that went here. Okay.
Okay.
Somebody else have something? That was pretty good. The trouble with this is the numbers were too big. Right? They were too big. Anybody have something else that we can look at real fast?
I don't remember the exact problem, but it was like a mortgage rate problem. I wish I had it in front.
Mortgage. Don't remember.
If,
Anybody remember that?
You know
It
what?
was-
I remember that too, and I
Yeah.
also got stuck.
it almost read
was
to
a-
me more like a ratio to proportion problem.
It was definitely a word problem. It asked,
Yes,
I think I got it down. I think I got it eventually, but if I remember correctly, it was something along the lines of for every $1,000
yes,
loaned, there
Yes.
was a $9 and some change fee
like
of
925, yeah.
something like that.
Eh,
So for every
yeah.
dollar borrowed or loaned, there was a fee, and the total loaned was $178,000.
Yes.
Yeah,
Thank you.
and I want to say that I ended up with the sum of it being it was like 1,700. The $9, I think it was like $9.18 or 17 or something like that. But for the sake of just doing the problem,
So-
that I'm sure that's fine. But
So the mortgage was 178,000.
Yeah, the mortgage on my problem was 110,000. So
Okay,
I guess they give
Yeah, but
different
it was-
problems.
everybody gets slightly different.
right.
Yeah,
So this
Right.
is the mortgage. We can work these numbers. And then go over this part again, how you remembered it.
It was, they said there was a $9.25 fee for every $1,000 that was loaned. So there was $178,000
Every
loan.
thousand.
But I think what I ended up doing was dividing 178 into 1,000 as opposed to 178 into 100,000. And then I got the
Okay.
answer.
So-
But it was a little bit tricky, just the way
Okay.
that they worded it and everything.
Yeah, so let's attempt to do this one. So if you had to borrow $1,000, let's just get this down. If you had to borrow $1,000, you would pay $925, that's it. Right?
Yes,
You
that's
are
that's
borrowing
what
a
they
lot
were.
more than 1,000. So how
Correct.
many are you actually borrowing? How many?
178.
178.
Yeah.
So each of those costs $925. So it's, when we only borrowed 1,000, we paid up 925, done. It's not the case, but I wanted to get this clear. As far as thousands go, we borrowed 178. What do you think you need to do with these two numbers to get the total fee? Is that what they wanted?
Yes, it was the total fee that you'd pay, right?
Shall we vote? How many people want to add these two? Sound of silence, perfect. How many people want to multiply these two?
Wanna add?
A multiply, I think I want,
How many people want to divide these two?
I want to divide two.
We had to stop at the multiply.
Okay,
Because here's how you kind of, you reason this out that it needs to be multiplied. If you bought 1,000, you paid 925. If you
Mhm.
bought or borrowed 2,000, you'd pay, what is that, 1850?
mm-hmm. Oh,
You see how this is going?
yeah,
So how did you get, but this makes sense, doesn't it? You only borrowed 2,000, so you pay your double, 1850. And then, but all of a sudden you get to one, you have to multiply them.
yeah,
And see, that's the hard part. Because, I expect they kind of wanted you to try it by hand. But the truth of the matter is, if you had to do it for sure, and you wanted to make sure you had it right, you pull out a calculator, right? Especially on some of these ones where the numbers are big. But it is multiplied. The calculator will not speak to you and say, oh my gosh, don't add, or oh my gosh, don't divide. The calculator won't do that. So it's worthless unless you know what needs to be done. That the reasoning is what we're trying to figure out, what needs to be done. Okay, is that okay? That's good that we pulled that together.
Yeah. So
Anybody?
are we allowed to use the calculator on problems like these?
Not on the test, but I mean,
Oh, okay,
honestly, I would definitely, but in practical, in your real life, you would, wouldn't you? But you need to
yeah,
a little be able to do a simple multiplication and then know about your decimal point.
yeah, okay, thank you.
Yeah.
That makes sense.
Anybody else have something? So we need to, when our batteries go dead, we need to be able to figure it out.
I have another question too.
Okay, let's see if we can do that, and then I'm going to go over to the review. Go ahead.
Okay. 3/4
3/4.
plus 1/4
Uh-huh.
hyphen 1/3.
You said hyphen, do you mean parentheses?
Yes. Parentheses, yes. Sorry.
1/3, yeah.
No, 13 over, no, the 1/3/4. One full here, 3/4. No, in the parentheses.
Okay. So is it 1/4 here?
No, here, in the,
So, okay,
No,
start
inside
right
the
here. Start right here and tell me again what to do.
okay. Yeah. 1/4,
1/4.
parentheses,
Is the parentheses here or next to the 4?
next, no, all.
Oh, okay.
1, 3/4.
Oh, 1 3/4.
Yes. Plus,
Plus?
yeah, again, no, don't close the parentheses. Plus 1/4, parentheses, square.
Okay,
Yes.
I had a pure mess here, so I'm going to make it This one, we did one like this the other day. Okay, so that's the problem I want to, so you're
Yeah.
going to do parentheses first.
Mhm.
Problem we did on Monday, or whatever it was, last climb, was like this, the 1 3/4 plus 1/4. Again, if you're thinking money, 1 3/4 and 1/4 make 4/4. And 1 4/4 actually makes 2, doesn't it? So 3/4 and 1/4 is a full 1, 4/4. That's a full 1 added to the other one makes 2. So what's good about this is this in parentheses ends up being 2. This is what happened before. Now, don't be tempted to add these because this is completely last. What's next is the squaring. So 2 squared needs to be 2 times 2, which is 4. So this is 1/4 multiplied by 4.
Oh,
Quarter multiplied by 4 is really 4/1. I would then reduce this. And so what I have left is 3/4, which I had from the beginning. And this is 1/1, which is 1. So an easy way to say that is 1 3/4. So the real thing here is once you got this mess out of the way, and again,
Mhm.
thinking of money makes perfect sense. 3/4 and 1 more quarter make 4/4. So now you've got $2.
Oh, so I'm not changing 4 times 1, just I'm not do that.
Yeah.
Mhm.
Okay. All right. Let's take a peek. Somebody, there was some chat and I didn't see what it said. Let's see. Okay, somebody's just leaving. Okay, so let's go over to XYZ. Now, where do we need? There we go. So, do you want me to start with fractions or decimals, or do you care?
Decimal.
Try decimals, do a little decimal. Okay, so this, when you go to this, so let's just do some of these, and I'm going to just randomly pick some of these problems, but these are the ones you should work on. Write the number into words. So we did this before, just with that other problem, tenths, hundredths, thousands, 10,000s. Okay, so it's 32 10,000s. Which of these three is the correct way?
The third one.
The third one is correct. Because they've got 10,000, which, when you count it over, we've got the 32 with a hyphen, which is good, and then the 10,000s. They like that, so let's go with it. Let's pick some odd ones. Write the numbers 73,000 and 383,000th with a TH. So notice the word "and" is your friend because it separates the whole numbers. So I'm thinking this is 73 decimal point. Now, 3, there's an "and," that's a decimal point. 383 thousandths. So tenths, hundredths, thousands. That's 3 places over. So everything's going to fit perfectly. 383. 383. What do you think? Are we satisfied?
Mhm.
Yeah, and so that's good. I'm gonna make this bigger, but let me just submit it to show you.
Mhm.
Whoa, something went wrong. Oh, I misread it. What went wrong? This is good. 70, I only saw the 73,000. You see
Mm.
that word right there? One,
Yep.
2, 3. That's 73,000. Now it's end. You think this is?
Can you make a little longer, bigger?
Yeah, so it's 73,000. So it has, the 73 has 3 zeros. I'm gonna make it bigger.
Yes.
Okay, my mistake. I was thinking of something else. 383 thousandths TH. That should be correct now. But that's why we practice. Let's try this one. Write the following numbers in order from smallest. Now, probably the easiest way to do this, there are 5 of them. The ones that have 3 numbers after the decimal point are easy to tell. The first 2, I would add a 0 to it, so it's decimal point 080. This would be decimal point 020, so it's 20 and 80. Which one is the smallest?
20? No,
This is the
2,
smallest.
2, yes, the
Yeah.
last one.
0.002. I think I need a comma. So that's the smallest. The next one would be
0.008.
008, wouldn't it?
Mhm.
Okay, so we took care of the last 2. Then this one, let's see, that's 82. That's pretty big.
Mhm. I think 0.02.
This one here, I think, is next. This is 20. I kept the 0 in. And then we have 28 would be next. Now I've gotten the plain 2, the plain 8, the plain 20, the plain 28. And now this next one would be the 80, 0.080, the first one. And finally, the biggest one is the third one down, 0.082. Let's see if I somehow got that right. Now I kept zeros on the first 2, and I have no idea if they're going to mark me wrong. So let's find out. Ah, you can mark it right.
Mhm.
Okay, so I think the trick was adding zeros to the 0.080, 0.020, and then every number you could tell. 2 was the smallest, 8 was the next was 20, the next was 28, the next was 80, and the next was 82. It was easier to judge. What are you talking about adding zeros? 3.70 subtract 2 decimal point 15. If you think of this as money, you can do it. And I'm into money today. Can anybody give me the answer? $3.
Round it.
How much?
We round it.
No rounding. There's no rounding instructions.
185.
How much?
185.
It's subtract.
One-
Be sure and subtract.
155.
Yeah,
One, yeah.
155. Let me just quickly bring this up. So what I did was I added a 0 to the 3.7, 3 7/10. When I added a 0, now it looks like money. I borrowed 1. 5 from 10 is 5, but I had to borrow. So then this is 6, take away 1 is 5, and then 3 take away 1 is 1. So $1.55, if you think of it in terms of money. Is that okay? So I added this 0 to make it look more normal. Questions?
Nope.
Okay.
Okay.
Okay, so what did I say? 1.55. Everybody has a different problem, so these answers won't matter one bit. Okay, I just want to make sure we're not making any terrible mistakes. Oh. A college professor making $2,097.32 per month has her check deducted for this much for federal income tax, this much for retirement, this much for state. We don't have state tax, that's the, but all right. How much does a professor take home? Do you understand this concept?
Yes.
So you have to add up the deductions, the 153.83, 67, and then subtract it from the total, which was 2,000. Okay, I don't want to take the time to do it, but as long as we're clear, that's what you need to do, is subtract the 3 deductions, actually federal, retirement, and state tax, and then subtract that full amount from that. I don't know what she's gonna make, but kind of went down. Oh, good one, I love this. When you multiply by 10, 100, and 1,000, it's a decimal shift. These are the easiest ones to do. It doesn't require a calculator, it requires nothing but moving the decimal point. How many decimal places will you have to move it?
2.
No, we're going to move it more than 2. The number of
One.
decimal places you move it
Oh.
is
4.
actually
4.
how many zeros you have. 1, 2, 3, 4. So we're talking 95.02 times, what is it, 10,000? So here's what I want to do. One, 2, 3, 4 decimal places. So I take my 95.02 and I move it 4 places. Now it's going to take 2 to get around this number, but I have to go 4 places. So we count them. 1, 2, and I had to add zeros, 3, 4. That's our answer. 950,200. How's that? So there's
Okay,
no calculation. It's all sliding the decimal, and to multiply, you move it this way to make it a bigger number.
If it was a division problem, would we just move to the left?
That's the whole thing. Division, I don't think they did them too many, but if it was division, it's the same darn thing, and that's why I want you to let's do this one just to show you real fast. If you're dividing by 100, the decimal shift goes the other way. This is why
Okay.
the metric system is so good. 1, 2 places, 9.45. So I have to go 2 places because division makes it smaller. So we have to go this way. 1, 2. So it's 0.0945 front 0. So get the decimal point position before you add that front 0. But notice it's 2 places as it was called for. So that's division. And I can't remember if they had a few questions like that or not. But these problems are the best. Can everybody see this? Back to the problem. I didn't want to do that. Ah. Order of operation. What has to be done first?
Parentheses.
Parentheses. So notice how you could think of this 0.09 and 1.3 need to be added. You could make it 1.30 to make it easier to keep things lined up. And then when you're done, you multiply by 1.01. So that's multiply because the parentheses will then multiply. So what's the answer to the two added? So I want you to see, this was 0.09 and this was 1.3, but I added a 0, so everything lined up. And so 9 and 0, is it 9? 0 and 3 is 3, decimal point, and this is 1. So in the parentheses was 1.39, then that needed to be multiplied by the 1.01, which was out front. So you just do that real fast. This is 139, this is 0, and this is again. So with any luck, that's right. So how many decimal places do I have to shift it over?
4.
1, 2, 3, 4. 1, 1, 2, 3, 4. So it belongs there. 1.4039. Okay, so I did it fast because I want to save time. But once you're done, it's 4. Total of 4. And then you've got it. All righty. Anybody else? I don't know. I didn't do that one. Okay, the whole thing here is having to do with what you have to do. So this is the word problem. If 1 cup of coffee, and that's true actually, contains 97 milligrams caffeine, right? How much would be in 2.5 cups? What do you think we have to do with the two numbers? I'll give you 4 choices. Add, subtract, multiply, divide. What's your answer?
Multiply.
Correct. It is multiply, because one is almost 100. So you might think of it like that, but 2.5 cups would be like 250, right? You know, if you kind of do a little rounding. And so they definitely need to multiply those two numbers. There's no rounding instructions here, right? So just write down every bit of the answer. So I'm going to just quickly do it. 97 times 2.5. 242.5. 242.5. Okay. And because they didn't say round, then just give them everything, the whole answer, not part of it. Let's see what this one is. Somebody asked about this. Write this number as a decimal to the hundredths th place. Can anybody tell us how we did this? 3 over
Yeah.
29. You have to divide it out.
Yeah.
What number goes on the outside?
29.
29 it is. It's 3 divided by 29.
Mhm.
I would put a decimal point after the 3 and add a bunch of zeros. I think there was rounding. Did anybody notice rounding instructions? Let me, hundredths. So they wanted it rounded to the hundredths. Okay. Can everybody see this? So I'm going to go back to the paper. Okay, so they wanted this number as a decimal rounded to the nearest hundredth. So this is tenths and this is hundredths. To figure out rounding, you really need to add one more zero so you can have a number to stare at and decide about that last place. So this is a whole number. I'm going to take this decimal point and bring it straight up. And so my first job will be 29 into 30 goes once. 1 times 29 is 29. When I subtract 30, take away 29 is 1. I'm going to bring the first zero down. 29 into 10 does not go. So I say 0. I'm going to bring another one down. 29 into 100. I think it's going to go 3 times.
3, yes.
What do you think? 3 times that 27, carry a 2,
Mhm.
87. So that's 13 left over. Now, why did I say, okay, I'm going to stop? It's because of the rounding instructions. I have the tenths and the hundredths, and I have one number after it. And so it's pretty much, I need to round that. Is this big enough to make this go up?
No,
No. So the answer rounded for 2 decimal places is 0.10. At this point in time, I'm going to add my front 0. I'm going to leave that 0 there because they said round it to 100. So I'm going to leave that number with even with the 0. Okay. All right. And if while you're at it, oh, they have some weird ones here. But this is, we're going to go shopping here. A dress that costs $64.99 is on sale for 1/4 off. What is the sale price?
do we multiply the 64.99?
What?
Do we divide it into 4 parts
I
and then
round,
subtract one of the parts from the total?
in my head, I rounded it up to $65.
Mm.
65. I
That might work. They're trying to get you to not do that, but probably with the rounding that's to the nearest penny, you're going to get away with it.
so a quarter of 65 in my head is $14, $15. So 15 take away 65.
This is what's being suggested. One, I think this is probably gonna, it won't get us in trouble. I don't necessarily recommend, but somebody, this is not a bad idea when, you know, push comes to shove. You might be off by a penny, which means you'd be marked wrong. But 1/4 of that is basically 65 divided by 4, which is 4 into 65. 1. 4 into that is 6. And this is 2, 5. So even though this is rough, that's how much they take off the price. So is that what they're selling it for or not?
You take off a penny.
Yeah, well, I see what you're doing. 65 take away 16.25. Honestly. We're borrowing here. Does that seem about right?
Yeah,
I think if we're wrong, and of course we did something crazy here, but if we're wrong, I think, let's find out. I want to see if this technique
I
is,
think that's it. Just take off a penny if we want. Take off 1 penny.
take a penny. I'm going to share my screen. Let's see, share there. Okay, so the sale price is $48.75, and we're maybe off by a penny.
Hey,
By a penny.
you said
Which way do you think it needs to go?
go down 1 penny.
One down. Because we tried to cut a corner. I knew we were in trouble. Let's see if they accept that.
Ah, I love it.
that was a good idea, Dan.
This is creative. This is creative math. There's a whole field of math called fuzzy math that I never heard of it until I was well into my studies. And I thought, that's the funniest thing I ever heard, fuzzy math. But it's math that you can't quite get a handle. I never did understand what was going on. Is that okay? So the proper thing would be to go, you could have divided this number by 4 and then subtracted it. And I think we have a rounding error. That's where the penny came in. And so they didn't want you to take that shortcut. It got us in the right direction though, didn't it?
Mhm.
But honestly, okay. All right. Now, okay, this is chapter 3, and I know our time basically has run out. Find the lowest common denominator and use it to perform the subtraction, the indicated operation. Can somebody remind us what the common denominator might be?
It could be
50.
even 5.
And 30.
5.
It's
Now,
150.
remember, the lowest common denominator is at least as big as the biggest one.
It's 150.
It's 150.
Oh yeah. Okay. Okay.
Mm.
We're gonna stop here.
No.
I'm pretty sure the, let me go. Let me finish this. Yeah. So it's like 5 into 15, it needs a 3. So 150 times 3, 50 times 3 is 150, and then 7 times 3 is 21. And then 30 needs a 5. Subtract 1 times 5 is 5. So this problem becomes 21, take away 5 is 16 over 150. Do you think they're going to accept that answer right there?
No.
No. It needs to be reduced. And the very clear thing is that this is even and so is this. So at the very least, you can divide both of them by 2. So 16 divided by 2 is 8. And 150 divided by 2 is 75. I'm just going to do it real quick. The only thing that divides 8 are 2's, and there's no 2's here, so that one is actually finished. Okay. So I'm hoping, expect the test will not be the worst of these problems, but they want you to practice some of the ones that are a little bit more challenging, just so that you can get, remember some of the skills.
Okay.
So are there any, I'm going to stop. Any last minute